think that is working. Okay, so we're very excited. So let me just welcome everyone first. So this is the Boston Society for Architecture Small Practices Network. My name is Kyle Barker. I'm one of the co-chairs. Susie Sanchez is the other co-chair. And we're really excited to have Andrew Frederick from Croft today. Andrew started Croft about 5 years ago now.
Yeah, actually 4 years ago, which
Okay.
is
It's just been
surprising.
a rip-roaring start. So 4 years ago, Croft is located in Mid-Coast, Maine and Rockland. They do, well, Andrew's going to talk about it today, but a prefabricated straw-filled envelope panel that's highly customizable. But the point of today is less like sales pitch and more to talk about biomaterials more broadly. So I'm going to let Andrew take it away. Andrew is also a designer in his own right. His house was recently featured in Dwell. And, I have been personally working with Croft for about 4 years, but thought that this was something that it seems like a lot of people are interested in and would be useful for a group. So thank you so much for joining us, Andrew.
Yeah,
I'll let
thank
you know
you.
if your sharing's working and all that stuff with the thumbs up.
Cool. Yeah, I'll pull it up and we'll see.
And also, actually, while you're pulling it up, people are welcome to stay off camera. Obviously, I know that sometimes people eat lunch during the meeting and stuff, so you're welcome to keep your camera off. But we also love when people have their cameras on. So no pressure, but it's certainly not like weird in the culture of these meetings to have your camera on. All right, thanks. Take it away, Andrew.
Cool. Thank you. Thanks for having me. I am excited to talk about really what is kind of a specialty for my company, Croft, and a few select other companies in the US and around the globe. And that's really focusing in on the use of bio-based materials in not only construction in general, but specifically in prefab, in panelized prefab. And as Kyle said, I started this company, I guess, right at the tail end of 2020, beginning of 2021. And we've grown quite quickly. And I think this is actually, we're just kind of riding a wave that a lot of other people already set in motion. But, to sort of jump right into what it is that we do, we make panelized prefab buildings of really any type, and we utilize primarily straw, super compressed straw, and that the specific reasons for that we'll get into, but primarily it's that these materials, straw foremost among them, but any plant-based material, have some really compelling beneficial characteristics, particularly when it comes to like carbon and climate. Part of working with these materials, especially starting back in 2021, there wasn't a heck of a lot of precedent for what we were doing. So, we had to like build our own equipment to make these panels. We had to build our own supply chain. You have to convince a bunch of people to get involved in the construction world who are not like well versed in how it works and how material demands work. But I've steadily built this company, and I think we're always looking at what are like appropriate ways to deploy design and technology sort of across what we're doing in ways that are always focused on this idea of maintaining climate friendliness and really carbon capture in everything we do. So part of that is not just like making these buildings, but it's also monitoring the energy consumption in our factory and the health of the farms that we're buying straw from. There's a lot of things that go into like that level of stewardship and care, but that's really that's why I founded the company, and thankfully why everybody who works there continues to show up every day. So this might be news to some folks. I think this is quickly gaining traction across architecture and engineering and construction sector, but buildings are like 40% of humanity's carbon impact every year, which is a really grim statistic, but it's also like a little bit promising, because if we can just solve buildings, we're like halfway done with a solution, which is nice. And a huge part of the impact of these buildings has been ignored in recent history. So we have been focusing on the operational efficiency of buildings. All of our energy codes, as they continue to update over the course of a generation, we basically like halved the impact of most buildings that are built to code. And that's great, but there was this sort of like unseen impact that no one was tabulating until quite recently. And that is like all the materials, the impact of refining and extracting and processing these materials. Like, we got to pull all this stuff out of its native environment. We refine it and manufacture stuff out of it, and then we utilize that stuff in our buildings, and ultimately we throw it away. All of those things come with this sort of cost to the climate, which is already emitted the day that we cut the ribbon on a new building. And we just weren't paying attention to that until quite recently. In 2019, some folks, Ace McCarlton, Jacob Racusin, and Chris Magwood, sort of unveiled their research at NESI in Boston, the conference in Boston, on this impact of the materials we use in our buildings, and they dubbed it embodied carbon. So it's sort of the upfront cost of making a building, and it turns out to really be the lion's share of most buildings. It is that upfront carbon, and it in a lot of ways kind of maintains its lion's share for a long duration. It takes many years of operating a building, of like heating and cooling and keeping the lights on. That sort of like operational cost adds up over time. It certainly does, and so we want to pay attention to how efficient our buildings are. But that upfront cost has like already been emitted on day one, and even after like 30 years of operating a building, it's still half the impact of that building is just like in the envelope, just in the building itself. So materials like glass and steel and concrete, and materials which take a lot of energy to produce, and then materials which actually just use a lot of petroleum innately, like foam. Those have huge carbon implications and climate implications in utilizing those materials. So again, this is sort of background stuff. Maybe some of you are already quite well versed in this, but there are like drastic changes available to you as a designer when you go out and make decisions about, like, for example, how you insulate a building. This is just a quick look at the impact of insulating sort of a generic like 2,000 square foot single family home with different types of materials. So on the left hand side, you have stuff like XPS foam, which that's so high off the chart here, really, not because of the foam itself, but because of something you might necessarily not think of, just the blowing agent to like fluff up the foam. They utilize pentane when they're making XPS foam, and that's like 1,200 times more damaging to the atmosphere than carbon dioxide. So it's these sorts of things that we might normally not be looking at that can lead to these huge impacts. And as you move towards materials like sheep's wool or wood fiber or cellulose, those are things that, in some cases you can get right off the shelf at a lumber yard, or your contractor can, and they actually capture and store carbon. But the one standout material amongst all these things turns out to be straw, which a few years ago I was not paying attention to at all. But I came across this exact information at a conference I was at, And it was compelling enough for me to kind of like reinvent my own business and how I was approaching construction. I had been doing high performance buildings for years. I had helped another company start a prefab program, but seeing the math on embodied carbon was enough for me to kind of pivot entirely. And it really does add up. Like if you were to, this is an example from, a sort of conventional approach to like an 8-unit multifamily building. You could have a building that looks like exactly the same on the outside and the inside. No one actually needs to know what is in the guts of that building, but you could move from 260 tons of emissions to the atmosphere with a quote unquote high performance building, or like passive house level construction made with things like spray foam or XPS foam. You would be emitting 260 tons to the atmosphere before you even start living in that building. You could make the exact same building with materials like wood siding and cellulose insulation, stuff that you can just get conventional off the shelf, and basically have the amount of carbon impact of that building. And then if you really go wild and do the sorts of things that we do at Croft and utilize like plant-based carbon storing materials, you can really start locking away carbon for generations, essentially for as long as that building lasts. For that same exact building, again, it would look the same in every capacity, but you could capture 146 tons of passively sequestered atmospheric carbon just by utilizing the right materials. So I came across this information and was like, okay, great. What do you do with this sort of compelling data? I think there's a case to be made for the sort of old approach of a straw bale wall system, but really people have been building that way for 150 years, where you just sort of like stack a bunch of straw bales up on your foundation and you plaster the inside and stucco the outside. And there's a lot of limitations associated with doing something like that. Not to mention here in New England, like horrific spring rains and all sorts of issues with quality control. So, my feeling at the time when learning this stuff was that this material has had plenty of time to sort of take over the industry for a lot of compelling reasons. It is incredibly fire resistant. It's vapor open. It's insulative. It is sort of inert nutritionally, so pests are not attracted to it. It has a lot of good things about it, which we can talk about later if we want to get into that. But no one was doing it. Like no one was utilizing this material, and it really is the most promising material. Like we could super insulate every new home in the United States with straw, just wheat straw, with the wheat that we already grow for bread and cereal and all the food that we eat in this country. And we would only use like 15% of the straw that we're growing anyway. And that's if we, built every new home to passive house level construction. We just have so much of this material on hand. But the fact that it wasn't getting employed consistently by the industry sort of seemed like this big gap of opportunity. So how do you just make it like inexpensive and easy and fast for people to utilize this stuff? And that was really the problem that, at least when I started Croft, that was the goal, to just change that and make it easier for people to employ materials like this. I know all of you here basically are running your own practice, and so you understand like the crazy obstacles of like starting your own business. I encountered the same thing when I started this company. This was in 2021. We got this. We signed a contract a few days before this. It was myself and one part-time helper at that time, and we got a delivery of straw to our freezing cold unheated warehouse a few days later. And That was March 23rd, and I had a contract in hand for a house built with compressed straw panels without any knowledge of how to make a compressed straw panel. So then I had to figure out how to do it, and built a machine to make these panels, which failed almost instantly. And so I then had to rebuild the machine itself. But 2 days later, we had the first element, which is sort of what we gang together to get our bigger panels. A few days after that, we had our first full panel. And then on August 6th of that year, we installed the first building. And that was like developing the product and designing the house and setting the whole building. And that was 5 days with a crane that summer. So it was a pretty intense load of like development in those first couple months. But we got there and have sort of steadily grown since then. And I think that's more a testament to how compelling these materials are than really anything like we're doing. We have sort of at least in-house, as Kyle pointed out, like here in Maine, at least we can design single family without a license, which I am not licensed, but we have sort of a rinse and repeat system for at least single family homes. We have basically like templates that we utilize that we can just keep sort of adjusting based on the goals of the client and program. And but they're all based around this panel-based system. So we've got a lot of flexibility that we might not necessarily get if I was to be in sort of volumetric modular, where you're really selling like a product instead of a building. And thanks to Kyle, actually, we're now moving into multifamily and even more commercial projects. And I think that ultimately, feels like the goal is have this sort of agnostic system that we can get biomaterials into, any kind of building out there. They just present such a compelling solution from both an environmental perspective, but also from a building durability perspective that, we want to be able to like serve whatever market, not just sort of bespoke single family homes. And again, I think anything that we're doing, we really are focusing on this concept of capturing carbon and improving, not just like doing something less bad, but like genuinely improving the environment. And our carbon capture medium happens to be houses, and the byproduct of growing all that grain happens to be food, and that is sort of a virtuous cycle. But regardless of whether we are building it or someone else is building it, these biomaterials are really like, if we want to be hitting our climate and carbon goals at the same time as addressing the housing crisis that we have all over the country right now, these plant-based materials are really like the ticket. If you just kind of like build a basic structure and insulate it with plant-based materials, you can get significantly more kilograms of embodied CO2 locked away inside that building than if you were to even use sort of next best options that are conventionally available. And like, hey, I get it. It's hard to sort of find these things on the market. That's part of what we're trying to solve for other people, so they don't have to like call up your local farmer and get a bunch of straw bales and then try and figure out what to do with them. But you can see how even just a building that essentially looks the same on the inside and the outside, you can have drastically different impacts just based on your material choices. So again, like chasing perfection is one thing, but even just thinking in baby steps towards these less impactful materials or even more beneficial materials is really like what I want to float past you. So we get like a gazillion questions about utilizing materials like straw because it seems risky. And I would agree with you, like 5 years ago, I thought the same thing. It is just astonishingly durable. The first question everybody asks is isn't that going to burn? And it does not. At least it doesn't without a fight. And if you have an opportunity, this QR code here links to a video that we made with our local fire department several years ago, where we actually built one of our panels and then built a code compliant wall and a spray foam wall and set them all on fire. And it was terrifying and a lot of fun. But it is astonishing how natural materials can stand up to conditions that actually are the materials that we normally think of in conventional construction actually underperform quite drastically. In terms of durability, straw just innately as it grows is bioaccumulating silica, which is the same stuff that all other insulations kind of add in to gain their fire resistance and their pest resistance and their rot resistance. And straw just naturally has it, which it feels almost silly that we've been ignoring this really compelling option for so long. But there's plenty of projects, particularly out in Nebraska, of all places, because they had a lot of straw 100 years ago. There are traditional straw bale built homes out there rounding 100 years of age. They're totally fine. And you compare that to even conventionally built construction here on the East Coast. This is a project that I actually worked on with a couple of friends. This is just a conventionally framed home that is falling apart after 19 years. And not because necessarily of materials, which I would like to point out, though OSB is not particularly known for dealing with moisture well. This is more about conditions. And I actually think that is, probably the biggest misunderstanding of all in designing for the use of biomaterials and just designing for durability in general is, even if we were all collectively to just take a deep breath together, we all at this moment, no matter where you are just inhaling billions of mold spores. Like it or not, this is the world that we live in. They are around us at all times. And the goal in making a durable building is more about creating conditions where those mold spores don't have any interest in living than it is about choosing a wonder material that is going to kill them off. And as you just saw, fiberglass and OSB can happily just sort of dissolve into compost if put in the wrong conditions. And straw can perform admirably if given the right conditions. So the way we build our panels, they are airtight on both sides. They are vapor open, so any water that ever gets in there can get back out. I think I have a lot of respect for physics, and we design so that these materials can absorb and resorb moisture, because any building given a long enough lifespan is going to see moisture at some point. And it's more about how it behaves when it sees that moisture. So thinking about conditions and not materials. And the other thing that I think gets really interesting, particularly from a design perspective, is thinking about how to sort of design for success. When you are starting to think about utilizing, even just dipping your toes into the water of I want to use cellulose instead of spray foam on my next roof. There are different implications for utilizing, vapor open materials or fluffy insulations or anything like that. That has been that's been actually probably the most surprising part of starting this company for me, has been establishing those guardrails for people, recognizing that the sort of design language of modernism arriving in the 20s and 30s really was arriving at the same time as prevalent use of steel and foam and waterproof rubber materials. These are all things that design language is sort of rooted in those materials. And so you can't just take a broad, slim, cantilevered roof and throw biomaterials at it and call it a green building and declare success, because they behave in physics and when exposed to ambient moisture and humidity and weather systems, like they'll behave slightly differently. So, we don't all need to be like physics professors, but it is worth thinking about just like designing with respect to particularly moisture, to move moisture away from your building and encourage airflow in the right places. We can get more into that, but a little bit of research into building science is always helpful. The idea of using effortless materials, or sort of like the Tai Chi approach to employing materials in your projects is always interesting to me. That like the closer you can get to utilizing something in its natural state, the greener your project is going to be. So if you can use straw as opposed to cellulose or hempcrete or materials that are fast growing and plant based, like that material is going to have a better environmental profile than something that has had to be refined or processed or had binders or flame retardants added to it. And this is like language that makes me a little bit squeamish, honestly, but I do think this idea of like comparing your project to a single white oak tree is actually like, it's how I think about what we do at Croft. And it sounds so cheesy, but like just consider that one tree, right? Like unmolested, that tree is going to stand for 600 years for a typical white oak. And one of those trees will provide habitat for up to 20,000 individual creatures. That thing is capturing and storing carbon. It aerates and enriches the soil. It can send and receive electrical and chemical messages without infrastructure. It generates food. It changes color with the seasons, and it cleans and detoxifies water. It's creating microclimates all around it, and when its productive life is over, it just like returns to the soil harmlessly and shares all the nutrients that it gained over the course of its 600 years with the next generation of life. Like that is a goal that none of us will be able to meet with our buildings, but like I dare you to try when you are designing something to like beat that standard. It is a high standard that has been set. And the other thing I think is like, I just want to point this out because I think there is a lot of excitement in the industry around biomaterials. Straw is a very compelling one. I'm delighted that there is that excitement, but no one thing is actually a silver bullet in this industry, including biomaterials, including renewable energy. We do need to think about sort of holistic solutions, and oftentimes that includes like fighting the good fight on density and zoning as much as anything, because we could make the greenest building possible, but there is a carbon impact and a climate impact to stuff outside the front door of that building. And even just putting in 300 feet of like road and wiring to get 1 acre per house actually has more of a carbon impact than your building has. And these are the sorts of like issues that I think we need to start thinking holistically across our industry and figuring out like, how do we bring in these partners on planning boards and code enforcement to be able to make truly, truly green projects. So as much as, I will forever tout the benefits of biomaterials and straw in particular, like these considerations are just as important. This data came from a report that was put together in Austria and Norway a couple of years ago. If you're interested, that little QR code in the corner will take you to that article. And they actually have a calculator where you could calculate the impact of your own project as well. So that's really, in a nutshell, like what we are up to at Croft, and sort of how we think about the employment of these materials. But I'm actually curious to hear if you all have questions or I don't know, inquiries about prefab in general or these materials in general. So I'll stop talking for a minute and see if there's any interest there.
Thank you, Andrew. Oh, that was a great presentation. Um, oh, perfect. I was going to say I'll get us started, but Kara has a question. So, Kara, why don't you go for it?
Sure. So nice to meet you, Andrew, and thank you so much for the presentation. I've been a fan of your work for a while through following Kyle's practice. I have a small practice of my own with my partner, sort of outside of the Providence area in Massachusetts. And I guess my question, I have a lot of questions, but my most sort of specific question right now is sort of around existing buildings and additions and how you would recommend or you might think about approaching those types of projects, because we're working in a semi rural but like adjacent to urban sites. So we do a lot of work in both contexts. And a lot of times we are really trying to be advocates for keeping what's there if we can. Of course, you can't keep everything, but how would you go about thinking about the modular, like the benefits of the modular system in an addition and planning for that? And then also maybe like extending that insulation to like re-insulating a vernacular New England building?
Yeah, great question. Um, you know, the Dutch really sort of solved this one already. As you can probably imagine, there's an approach which is definitely worth a quick Google. It's called energy sprong, energy spelled with an IE, SPRONG.
Mm-hmm.
Um, and energy sprong it's sort of like the high and low tech mix of, they essentially show up and scan the outside of a existing row house or single family home, and then off in a factory somewhere create a bunch of panels and then show up and clip those panels to the outside of that building. That sort of requires like a level of coordination and uh, pre-existing building stock of such a high quality that I don't know how applicable that is to the US. I will, give the like lift the hood just a little bit on the fact that, at least at Croft, we have two products that we're working on right now that will allow people to kind of do retrofits without purchasing like a whole structural envelope from us, because that's obviously a lot more than you would need for a retrofit application. And probably the other note on that is like, it sort of depends on the building, right? Like
Mm-hmm.
if you're particularly our masonry buildings, which are just like everywhere, like there are brick buildings in every downtown in New England. Um, they are really, really difficult to retrofit well, um, without insulating to the exterior. Insulating to the exterior is absolutely going to be the sort of like swiftest and easiest and probably arguably most cost effective way, but nobody wants to cover up those historic buildings,
Mm-hmm.
and so you end up like at loggerheads with historical commissions or the town themselves because they want to preserve the town character, or sidewalk clearances or whatever the issues may be. So masonry buildings are a tough one. I think historic vernacular buildings, when you just have like a stud frame, like the same as we're still building today, those applications are a lot easier to deal with, and a lot more easy to like detail in a durable fashion than the more urban context, I would say.
Cool. Thanks.
Yeah, yeah. Did I get all the
Yeah.
bullet
No,
points there?
definitely.
Okay.
I will be in touch with you offline about those options, because I'm definitely we're going to be sort of developing our own kind of project. So I might be a client of yours as well.
Cool.
So yeah, thank you.
Yeah.
Tom, did you have a question?
Yeah, I did. So thanks so much, Andrew. And just a question about sort of the regional availability of panels, because there's just so few manufacturers today in the U.S. And I'm based in California, and there was a project that happened in the Bay where they were using Eco Cocoon, or so. Yeah, do we need more manufacturers of panels in the U.S., or if we're in California, should we be shipping these panels there, given like the cost of shipping and that sort of thing?
Yeah, early days, I would say there should be, to answer your first question first, there should be more manufacturers. Uh, it's funny, I was just co-presenting at Nessie this year with another prefab manufacturer, and we did a bunch of research into the prefab industry as it exists in the US. And there are like beautiful precedents that are set around the world as to like how to do prefab efficiently and economically. And we just cannot do them here in the US because of a whole host of factors, which I don't need to get into at this moment. But I would love to see more people manufacturing these panels. You know, I think while I agree with you that we should not really be shipping panels across the country, that doesn't totally make either economic or sort of climate sense. Straw is such an incredibly powerful carbon storage medium that you could actually truck things across the entire country and take about a 25% hit on the carbon capture. So like we could do it. I don't love the idea of doing it. We are just about to send a project to Montana and ran the numbers on it, and it still comes out in our favor. But I think it's also worth like I do agree with you on this aspect, and so I'm not trying to create a sort of like whataboutism here, but I do think it's worth like pointing that same question towards all of our materials that we utilize. Like as soon as we get into the world of biomaterials, we do get this question all the time, like how far are you shipping it? And I've never heard anyone ask like how far did you ship your mineral wool or your fiberglass? And I think it's like we should ask those questions too. And that's all I would want to point out on that last aspect. Like I agree with you, and I want there to be more straw panel manufacturers, though. Absolutely.
Jeffrey, do you have a question?
Yes, I do. And that was regarding the fire testing. And I've watched the video before, and it's certainly convincing in principle and all. That being said, for adoption beyond, like type 5 buildings, that's certainly a hurdle. And I was wondering if there are any plans for, some sort of, ASTM or NFPA level testing to allow for adoption on a broader basis.
Yeah, we actually went and got ASTM E84 certification for our material, which, ironically is just straw. Like there's we didn't add anything to it, but we packed it up and sent it off to a lab and paid for the testing. And it is Class A according to ASTM E84. So we have that certification. That said, making the leap into anything except I think it's type 4 HT, where you have like a mass timber frame that is actually a fire rated structural assembly, and then you are allowed to clip a semi-combustible assembly with fire retardant treated lumber on the outside of that building. Like we could do that right now, but I actually don't know that there is a future where biomaterials ever play nicely with anything except type 5 construction and type 4 in the right circumstances. And so I think that's actually like it's worth pointing out, like those are not I hate to be the fox in the hen house, but like those are inherently not sustainable ways to build. Like making a 17-story high rise with glass and steel is like not going to be sustainable from a climate perspective ever, which is like an ugly truth, but it is a truth.
What about kind of encapsulating the combustible or semi-combustible material within non-combustible? Is that something that you see as viable?
I don't know that it's in the cards for us to take on. In order to get a non-combustible material, we could look into sort of a line-based plaster encasing element. But as soon as we get into like cementatious materials or steel, the carbon profile of those materials
Jumps
is
up.
so high that I don't know that there's a heck of a lot of interest on, at least on our part. I'm sure like at some point Owens Corning or DuPont is gonna like catch on to this trend, and you will probably see those marketed someday. But we have looked into essentially like precast lime-based plasters in our shop, and one of the issues we haven't gone with it yet is it becomes fussy and labor intensive on site, and it's incredibly heavy. Right off the bat, it adds like 10 pounds per square foot on either side of the wall. So there are sort of logistical reasons that we've avoided it, but I'm not opposed to that sort of thing. It's just a whole other line of R&D we would have to get into.
Sure. Well, thank you.
Thank you.
Well, I can ask more questions. Thanks for the presentation, Andrew. I think that was really like, it was great to see, like, to kind of zoom out on all the work that you're doing and like contextualizing it like that. I guess I was wondering, I think I was trying to think about the things that people ask a lot when I tell them about the projects that I'm working on. And I think the questions that often come up, many of which you talked about, fire, rotting, all those kinds of things, which I think are interestingly also questions people don't ask of other materials, Foam is so flammable. Nobody ever asks me about foam insulation. But like how you think about incorporating systems into the assembly, like penetrations in the envelope, but also like outlets on the interior side of those exterior wall panels, like kind of what is Croft's attitude or solution for like those kinds of challenges?
Yeah, that's a good question. Having sort of come at the creation of these specific panels through the route of like being a site builder, that was like really integrated from day one. I actually think that's one thing that I will be psyched. Actually, someone brought up EcoCocone earlier. Like, it'll be great when EcoCocone sort of like latches on to making it easier for site subcontractors in the US, because it's just difficult to integrate plumbing and electrical. Like it's hard to convince a plumber to like route out a compressed straw panel with some bespoke specialty tool so they can run their plumbing lines before everything gets plastered. So we sort of try to get ahead of that to a certain extent by on this slide there's this little exploded ISO of our typical assembly, and normally on the interior face of the wall we have a smart vapor retarder, which provides sort of the first air seal of two redundant air seals in the wall, and then inboard of that we put horizontal strapping, which as a general rule we will just go with 1.5 inches of depth in that, which allows for shallow outlet boxes on your exterior walls. It doesn't really have enough room, if I'm being honest, for like plumbing vents and that sort of thing. So oftentimes we will just work with a designer and say, oh, okay, well, there's a bathroom on an exterior wall, you have a sink on that wall, and we need to get a vent there. So why don't we just bump out the depth of that service chase just in that one room? And that's the sort of thing it's actually quite easy for us to do in the shop. It's also easy to add those things in the field, but that sort of integration with all downstream subcontractors, I think we're pretty good at it now, and I'm always listening to feedback to say like, oh, actually people would prefer whatever, whatever changes in order to make that easier and faster. So
Cool.
But yeah, that service chase allows that for that right now.
I guess the kind of second part of that question is like for things like line sets, for mini splits, and like things that need to go from outside to inside, like kind of what is your solution for that, or how do you plan for that?
Yeah, it sort of depends on how much of that information we have going into the design process. But if the design is really solid and really done, and we have like an MEP plan, we'll just put like gasketed chaseways in everywhere for ductwork or electrical lines or heat pump line sets. So those folks don't even need to drill anything. They literally are just like pushing a pipe through a gasket, and it's air sealed without anyone having to care about an air seal or taping or anything. Again, I like, not everyone is super well versed on high performance building. And so I think the more like plug and play we can make it on our end, the more we can get the industry to adopt these materials, which is the real goal.
Andrew, how thick are the panels for walls, and then how thick are they for roof to meet the energy?
We basically can do any thickness, but we stick with this double stud wall. We have a 12-inch and a 16-inch, and that's more about like material efficiency than anything. But that wall the 12-inch wall is about an R45 with the way that we process the straw, and the 16-inch wall is about an R60. And our roof assembly, which I think I have a cutaway here. Our roof assembly is 24 inches thick as a general rule. Every project is a little bit different, and we oftentimes will do some wildly bespoke assembly for someone. But again, we have found that it adds costs and complexity, and we sort of like know our wheelhouse well enough that when people are like, oh, can I change this or change this? We sort of know when to say like, you could, but you probably don't want to. And I think part of this idea of environmental friendliness and holistic solutions is like, towing the line on making high performance just a standard. Like in the case of the way we're building, it's actually kind of a virtuous cycle. Like you insulate more and you're storing more carbon in that building, and that building is better for the environment, and then it's consuming less energy for its 1 to 300 years of life. So I personally feel a lot of conflict about like building anything at this moment where we're putting like a boiler in the basement and heating and cooling that thing for the next 100 years, like when we don't really have to. The cost to performance vector is quite small at this point.
And what's the R value that you're getting on the 24-inch brick panels?
It's about 85, R85. So it's, we're basically everything we're doing is kind of to the passive house standard, just as a general rule. We did a project with Kyle in Freeport, Maine. It was around like 3,100 square feet or so. And we got a very sweet email from the MEP engineer who said they could not find a heat pump small enough for that house, given the performance of it, which was quite a redeeming email to get.
Can you tell us about this rock burrito on the left here, like the foundation system on the drawing on the left?
Yeah. This is a foundation system, which it's funny. Pretty much everyone who comes across this foundation, which we do on lots of projects, it strikes people as very fringy, except for the structural engineers who look at it, who are just like, yeah, every other building lands on a compressed bed of aggregate, so you just moved that up. And this is basically a zero concrete foundation that we've done with great success. It's compacted glavel, which is it's like an aerated foamed aggregate or glass aggregate, which is made with recycled bottles. And so it's like a backfill and an insulation in one. And we excavate the perimeter of the building and the field to about 18 inches. The perimeter is excavated to below frost line. and we compact this aerated glass aggregate into that trench, and then wrap that in filter fabric and cap it with a granite block of all things. And granite is incredibly prevalent here in Mid-Coast Maine. It's actually like really inexpensive. We can do a single family home foundation for about $4,500 in materials, which is just like ridiculous. And we don't have to use any concrete, which concrete has an incredibly high embodied carbon cost. It also acts as a moisture wick, so you got to be very careful about your capillary breaks. And ironically enough, even though there is a cement factory literally a 4-minute drive from where I'm sitting, all of the Portland cement in Maine, or at least Mid-Coast Maine right now, is being shipped from Spain. So anything we can do to avoid using Spanish Portland cement at this moment feels like a good climate move. Oh, someone just asked about helical piles.
Yeah, I'm just going to read it just for posterity when people watch a recording. Tom asks, I've seen helical piles on some of your projects. How does this compare to that? I guess that's appropriate for slope sites.
Helical piles. We have used them in the past. I'm not like in a rush to use them again. It might be as much to blame the local contractor who installs them as it is the product themselves. But we've run into a lot of tolerance issues. And so, which is fine if you are designing with that in mind, that you're going to have things that are as much as 3.5 inches off tolerance. We were not designing for that. And so we ended up in some serious headaches and incurred costs as a result. Technoposts and metal helical piles are, they're a good solution, I would say. They are inexpensive. They install very quickly. I do have concerns about just the longevity of something that, whatever, just like having been a site carpenter and having seen what happens to even like hot dipped galvanized steel over the course of 50 years, I worry about like putting an entire building that I feel very good about lasting over 100 years on top of a foundation that I have questions if it will last 50. So in the right applications, I think metal helical piles are great and useful, but as a general rule, I think we try and find a different solution before we utilize them.
Okay. Do we have any more questions out there?
Yeah, I would ask one just sort of in general, kind of about these panels. You know, like I've looked at the EcoCocoon, and it's very hard to find details about like how they do the compaction, and then they have this new automated factory, and it's like, what's going on in there? How do all like the manufacturers of these panels compare? Are they really different? It seems like people kind of guard like how they compact the straw.
Yeah, I would totally agree with you. And you know, early days, I was definitely sort of looking at EcoCocoon as the gold standard and trying to figure out exactly how it was that they were packing their panels. I think very early days they were just hand packing, and you know they were based in Lithuania. There aren't huge labor protection laws there, and so they were able to have like incredibly inexpensive labor to hand pack straw panels. They did just invest just last year like $10 million in a very nice automated factory that is producing panels at a just like unbelievable scale. It's awesome. I think like I applaud the effort to get as many straw panels onto the market as possible, but in the interest of like holistic solutions, I am hesitant to like put too many eggs in one basket. And though I feel strongly that biomaterials should be utilized in like every new building that gets built out there, and even every renovation, I also think there's this like call to action on like housing affordability, which means human beings need good paying jobs. And if you create an elegant system that is easy for people to learn, then they can have a good paying job making healthy housing and not be poisoned by nasty materials, which are currently used in the construction sector. It just like gives this path to entry for more people. And I don't know, that sort of like everything all at once solution feels like I don't necessarily just want to throw automation at straw and then say we've like solved the problem. Because there's like so many other facets to the things that we're simultaneously trying to solve. It's also just, even if I wanted to in the US, it would not be advisable to build a mega factory, because literally everyone who has done that in the US, if you all don't know about Katerra, it's a fascinating story. They had $6 billion of Silicon Valley funds, and they just imploded because here in the US, you just literally cannot put projects on foundations fast enough to pay for automation. So these are like internal considerations that it's just an entirely different marketplace in Europe. They're like much more set up to streamline projects, and they trust that people are going to build quality, whereas our marketplace is sort of set up to catch bad actors instead of trust good ones, which is fine. It is the conditions we have though, and I'm sort of trying to meet those conditions.
I think we're kind of right at the hour. If anybody had any last burning questions, then I think we could do one more. All right, I think we'll call it.
It's like we're good.
I think we're good. Thank you so much, Andrew. That was super informative, inspiring, etc.
Yeah, thank you.
Taking the time to do this, and thank you everyone for coming. We recorded it, so hopefully it will be up on the BSA's website in the next month.
Awesome.
All right.
Thank you, Kyle. Thank
Have
you
a good
all.
one, everyone.
Thanks.
Yeah.